All right. So this next session is on hardware error reporting. Standardization is one of the activities that's taken by hardware fault management sub-project. This is led by Jeff Order, who is a distinguished technologist at HPE, and Rama Bhimanaduni, who is a principal engineering lead at Microsoft, and Antonio Hasban, who is a principal engineer at Intel. And I'm here to, because of the travel restrictions, none of those could be here. So I'm here just to accommodate moderation of the session. So Rama and Jeff, please take over.
Hi, thank you, Kesh. Hi, good afternoon all. Thank you for joining this session. And I'm Rama. I work at Microsoft Azure Hardware Infrastructure team. Can you?
I'm sorry, and I'm Jeff Otter with HPE. So I know we're running already 5 minutes behind, so we'll go ahead and get started.
Yeah. Let's start with the problem statement. Like at the cloud scale and edge infrastructure consists of heterogeneous hardware to support multiple workloads like either memory optimized, compute optimized, or ML workloads. Okay. One of the major pain points we see is hardware faults causing interruptions to customer workloads. Okay. Like the two critical solutions we adopt to address these pain points is having a error resiliency features across the firmware software stack. Other one is providing error telemetry, describing all the hardware error details, okay, which can reduce these interruptions to customer workloads. In this presentation, we are going to focus on the error reporting, standardization, what are the problems, what is the solution scope. Like currently, like most of the error reporting solutions uses a IPMI cell-based, like which has many limitations as industry people aware of it. Like it can only hold very small amount of data and does not support all types of hardware errors. And also IPMI spec is becoming obsolete, right? And as with these problems, hardware vendors end up supporting custom-based error log solutions. It depends, the error log format can vary, depends on the type of hardware error and also like which agent is handling the error. Is it a BIOS, BMC or OS, right? And because of this custom error log solutions, many times we find some bugs due to validation gaps because it's not based on the standards, okay? We end up doing a firmware deployments to fix those bugs, which again can cause customer workload interruptions, right? And this gives a lot of burden on hardware vendors where they get the different requirements from CSPs and other vendors. They need to implement custom implementations. Standardizing will help even the hardware vendors. And other way, this custom error log solutions impact like CSPs, like as Microsoft and others, similar like Google Express, same problems and other vendors, okay? We need to develop multiple tools to process these custom error logs, to integrate into cloud hardware manageability stack, right? Even for CSPs, it adds a lot of complexity, time to market whenever we bring the new SKUs and operationalization of component. And one more critical impact we see is because of these custom implementations, we have a big volume of data, as Anil presented previous talk, right? And one of the critical main functions each CSP does is fleet monitoring and taking a preventive actions. Okay, the fleet monitoring, we use the machine learning tools uh, to understand these errors. But when you have custom error logs, this tool's complexity gets increased. And also for these tools to take corrective actions, the error need to have all the details about the error, because a cell and other things only supports very small records. You don't have all the sufficient data. And due to the limitations of the data, sometimes we cannot take actual corrective actions like replacing exact root causing the problems to meet our SLAs. Okay, like to address these problems, at Open Compute hardware fault management workstream, we are working on modern standard-based solutions which seamlessly integrates with fleet management stack. Like over the last few months, the V team effort between different companies. We looked at the first thing when we started looking at it is what are the requirements, right? So that it can be future fit for next few generations minimum, right? Let's go through the requirements, and the first one requirement is like having a autonomous near real-time flow isolation for all types of hardware errors. For example, different type of processor errors like CPUs, GPUs, and there is new processing capabilities coming like DPUs and all the things, and memory and PCI. The second requirement we have is like having a structured data so that you can develop tools easily and process these errors. And this hardware error reporting also need to support like the filtering categorization so that it supports multiple hardware error types, severity of the error, and error record. Other requirement we have is the ability to extend the error information into the error record. Some errors require more information, and it should provide that flexibility. Okay, and also other requirement is whenever you get a new type of hardware devices, those errors, how do we extend this to report those new type of errors, for example, CXL and other new technologies. And other critical component to seamlessly to work is how does it can work with existing fleet management tools. Okay, with that background of different requirements, we looked at different solution spaces, and instead of coming up with a whole new one and getting broader adoption is very difficult, we would like to see at existing standards, okay, and see what are the things we can take from existing standards, utilize those standards, okay, next slide. Yeah, when you look at the existing standards, we already have a UEFI spec-based common platform error record, which can provide extensive hardware error record information, like about mission check architecture errors, PCI AER domain errors, even new CXL based. It also supports multiple processor architectures, x86, ARM, and all. Okay, instead of, we want to utilize that already existing error record format, okay, and also the advantage of this is the tools to understand this is already available, because CPER is already used in the BIOS and OS firmware, faster OS firmware implementations, okay, and one of the drawback with this is CPER is not useful the way it stored the data in the UEFI flash. It's not used for like out-of-band management. It does not define any secure network transport. Okay, and how to solve that problem is we look at all the out-of-band system management. Like we are using Redfish for all other purposes. Redfish is being broadly adopted, and even for there is more like adoption is taking place. Okay, and but what we saw was DMTF standard provides a lot of support for all scenarios for hardware fault management. We have seen some gaps to have like extensive information about having a message registry that can explain about this platform level hardware events, and whereas it is a V team, by working with all the companies as part of this work stream, we are working on publishing that registry and contributing that. Okay, and one advantage of this DMT is already provides a lot of framework. It's not that you need to do it fully. Like Jeff can share more those details. Okay, at high level summary. Okay, there are multiple problems with the standardization. We want to help hardware vendors, the CSP vendors get benefit. Okay, not developing custom tools, and we can use for fleet monitoring and taking corrective actions. And instead of coming up with a new standard, we want to connect the dots, okay, and provide the rich set of error data through out of band also. Jeff, you want to go?
Sure. So yeah. So as Rama said, so the Redfish standard already has support for error logging, and or just general event logging. And so the piece that we didn't have was the ability to attach large amounts of binary data. If you can show on the next slide, the way that the way that we do this is by adding a new property to the Redfish event log format, and that's the one that's highlighted there in red. And actually, the property was there. We just needed to add a new type, and that is this the CPR record type. And so what this allows any implementation to do is to attach or provide a link to a binary blob of data, which could be a kilobyte, could be a gigabyte, whatever that that crash dump or whatever that CPR record actually ends up looking like. It can be attached then to this error entry. So when that event is transmitted, you're not sending that gigabyte of data if it's that big, but just providing the link so that a client, if it's actually aware and can decode and do something with that data, it's able to go retrieve it, separately. So on the next slide, the work here is really to define a message registry, which is the Redfish terminology for effectively the list of standard error messages, and so that the message registry provides both a human and a machine parsable list of supported error messages, and it provides implementation details, explanation of how the parameters work, and also allows for translation into other languages. So the other piece of this is that we can build a message registry specifically for the types of errors that we're talking about that are covered by the CPR records, and define that for the industry and build it over time. We can add messages as we go. So we're going to start small, use a message for effectively for the machine check errors. Perhaps one for correctable versus uncorrectable, and then see what else we need to define there. So that's where we're really looking for feedback. So if you can show the next slide, we'll show creating these message registries are actually really simple. This is an example. This is actually a real live one, just showing what one entry looks like. So you can see there's a description, and all the parameters, that explain how to fill out a particular message. The important part here is the actual name, which is the first line there, and that is what is used as a key value and what is actually transmitted along with the parameters and the other pieces of critical data. So none of this text is actually transmitted. This is all available on the client for decoding and translating if they need to. It can be also retrieved from the service. So so you can you still have full support of this with or without internet access, for instance. So on the last slide, we'll move our call to action here is really help us define what this registry should look like. If we're looking for use cases, what information is useful, how many different messages should we create, or is it just seed the CPR data for more information? So that's the kind of things that we need to look at, and again, we can add them over time. So looking to start small and move from there. But so join the group. There's the document that explains the requirements is shown in the link here in the presentation. You can also talk to us directly from either the Redfish forum, through the DMTF, through the feedback portal on the DMTF, or even through the public message board. But most importantly is join the mailing list here for the error logging project. And I'm also going to just join in here real quick. I know we're running short on time, so I'll also ask Antonio to join us now for if there are any questions.
We have about 40 seconds, so thank you, Rama and Antonio and Jeff. We can probably take one question if people are kind. Are there any questions for our presenters today?